All right, we go. Hey everyone, I'm Harish. I work at Mina Foundation and I manage the Navigators grants program. Thank you all for tuning in to the second day of the demos. The Navigators grant program has been running for 6 months and the first season has now concluded. At its peak, we had 65 participants and around 50 projects. During the demo day, we have invited 12 teams, and these teams are competing for a prize pool of 225,000 Mina. These teams have done exceptional work, and we are very excited to share with you what they have built over the last 6 months. Uh, the format of the presentation is every team has approximately 20 minutes to speak about their work. And the last 10 minutes are reserved for Q&A from the audience. So if you have a question, please put them in the chat and I'll read out to the team. Now I'd like to welcome the very first team from Mina Playground. Arnaud, the stage is yours.
Yes, thank you. Let me share my screen. So can you all see my full screen presentation?
Yep.
All right, so yeah, I've worked on Mina Playground. It was also previously funded in cohort 1 and 2, but the things I will show now were worked on during the Navigators program. So with Mina Playground, the idea is kind of to create like an all-in-one platform for Mina protocol where you can create, test, run ZK apps and smart contracts, and also some tooling to deploy your own smart contracts, follow interactive tutorials, and create your own projects with ease. So first you can follow interactive tutorials and run the code directly in your own browser. You can run examples, also new. So you can run smart contract and ZK app examples. You can also create snippets. For example, if you have some smart contract code you want to share, you can just copy paste it and all the code behind the smart contract is already there. So you can just have like one small example file you can share and also run in your browser. And you can create, test, and run smart contract projects online. So I'm going to talk first about the progress, and after that I will talk about the future, and then I will give a small demo about the functionality. So in December, I first worked on some extensions for VS Code, especially for VS Code in web. It's like an online environment. For example, vscode.dev, it's a website, which is basically a web VS Code IDE. So I've created a VS Code web container extension. Web container is like a way to run the code in your own browser. Also, it runs locally, so it doesn't share anything. So I created an extension for that, which supports all kind of different things. For example, you can spawn a terminal, you can run commands, you can run ZK apps, smart contracts. Then I worked on a VS Code Mina kit, which kind of combines the web container extension and some additional tooling, especially the deployments through to the extension. That's the first screenshot you see here. So that's how I kind of started, but I also find out, there were some difficulties to integrate that, and I also wanted to focus more on the Mina Playground itself and the learning integrations, for example, interactivity. I will also talk about that later here. Then in January, I worked on a lot of IDE functionality. Example, a way to fork public projects. You can see it here on the like a small fork button, so you can like copy an existing project, create a dependency management. So you can see that also in the last screenshot, where you can add existing packages, project management. You can see that in the first screenshot. So you can create, manage, delete, etc. The projects. Create a different tutorial mode. So because I wanted to have like a different set of things, like for example, you have like a playground mode. I'll also show that in the next slides, but you can just execute some code in there and run it in your browser, and you will see the result. But I also wanted to have some other things, like for example, unit test mode, which runs a specific unit test, and then it checks if it's passed the test or not. So you'll get a direct result from the unit test. Yeah, I also created some version control, some basic, like my own basic integration. You can see that on the right here, like commit changes. And then some other generic things where I've reused the web container process and installation of O1JS for all tutorials, which speeds up all the rendering of the tutorials. And also made it more efficient, only returning specific files. But I can also show that in a demo later. Release some things, solve the memory issue, and create like a small implementation of Next.js and React using different components. That was more like a small package that I use. So in February, I released the IDE on production. Also created something. It's like a real playground page. So you can see it here, the last screenshot. So it's like a list of examples that you can run and select. So you can also choose ZK app or a smart contract. So the first screenshot is it's actually running a ZK app. You can see the result here on the right. And the second one is just some code from O1JS that I render there. So it is different from the tutorials, because this is just like the tutorial. You have first the tutorial, of course, and then you have to integrate it yourself and then run it. So this is already shows you everything. You can just directly run the examples, go through the examples, etc. So in March, I worked on snippets. So you can create snippets for smart contracts and ZK apps and share them. I've worked on GitHub clone. It's like you can just copy paste a GitHub URL, and then it will clone that repo, and then you can run the code in your browser. Worked on 3-click deployment. This is also what I want to continue with. It's like a way to make it really easy to deploy a smart contract as a new user, or just with a few clicks. I can show a demo about it also later. And download files. So if you have your project, you can download the project files. So here you can see an example of the snippets. I'll also go through this in the demo. Here you can see a way, because the 3-click deployment takes some time. So on the left, you see it just to wait for the transaction. But you can automatically use the faucet to fund your address. You can generate your own key. And then you can just deploy it. So for the future, I want to use, focus more on interactivity. So what's next? I want to introduce a unit test mode where you can require successful completion of specific unit tests to process through the tutorial. So you can also think about challenges or specific things that you have to pass in order to continue. Also, kind of make it like a gamification experience. Make interactive tutorials and playground examples from community projects. Implement user authentication and leaderboard. where you have to pass a specific unit test and challenge. So now I'm going to demo something. I think I saw or I heard something here, but I don't see a message. So I will just continue. So first I will show the Mina playground. So for example, here we just have the tutorials. So you can, how it works. It first installs a base. I will show the code as well, but first go through this. So it first installs a base. It could be a ZK app or a smart contract code. And then I only show this file to make it really easy for the user to see things and run things. So for example, you can now just run. This is also what I've worked on during the cohort 1 and 2, but made a lot of changes here as well. So that's why I also show this. So for example, I change is also how I set up all the logic. So for example, now if we go to another tutorial here, you can see it's instantly. It doesn't require reinstallation or the web container to reinitialize. It's just instantly. But as soon as we choose a different, like a different category, it also still initializes the same. But as soon as we have another one, so I don't have that right here, but as soon as we have another type, so for example, where we have a ZK app, then it renders another base and installs that once, and then you can just go through all the items here again. So it's like a performance benefit, because you don't want to install everything each time you go through different tutorials. You just want to go through it quickly. So something new I've also created were the examples. So as you see, this looks a little bit different, but it just has all the code already included here. So we can just run it. Now it will not render anything because it's correct. We can change it, for example. Yeah, so now it complains because it's incorrect. So as you can see here, it renders instantly. If we choose another one, it's also instantly. But as soon as we go to ZK apps, it will install another base. It will also automatically install everything. And now if we click on run, it will actually run the ZK app here. So it takes a while to load this page the first time. Probably takes like a few seconds, but also, so here it is. Oh. So we can also update it here. So I do have to fix this syntax highlighting. So here you can see it's re-rendering. The first time also takes some time, and then after that it's almost instantly. So here you can see 2, 3. So that's also working. We can refresh it manually and do things like that, or just stop the process. Then we have the snippets. So here we can just put in something. It doesn't matter what we have here right now, but we can, let's do something like, so we can here create like a snippet. So if we click on create, it will redirect to a new URL. So we can actually share this, and then we can share some smart contract functionality. So right now it already integrates all the smart contract code. So we can already run a smart contract code in here. For example, if we take an example from the previous page. Yeah, and also have like, but this I already had, but it's like the IDE. I kind of finished it up with some functionality like the dependency manager, forking. I don't have it enabled on production right now, but I don't have that much to show here right now, but we can just run it, for example, npm run test. So mainly worked on, as I showed in the presentation, added functionality to the IDE as well. And then another interesting thing I want to show, I actually switched to my local host right now because I don't have it on production, is the deployment. Now it initialized the deployment, so this is also new. Here we can just do a deployment with, basically 3 clicks, maybe 4 or 5, depends if you have to fund your address. But so change your contract code. We already have the example here. So we can just click next. So we can either generate a key here, which we're going to do first. Then it says, oh, make sure to fund it. So we can fund it. Let me just click on here to automatically fund the address. This is your private key, by the way. So you can just keep that for another time or just only use it for this time to see the deployment. So this is going to take a while. So I will start it again with my previous key, but you can actually see the transaction here. So it's pending. So after that has been finished, I will now just use an existing key. Let's try again. After it has been funded, it also detects when it has been funded. So then you can go to the next step. We don't want to wait that long. So we now just use my previous key. We click on next. Then we click on deploy contract. What it will do now, it will take this code on the left, this example code. We can also adjust it to our preference, and then it will take the key that we generated. It's also funded because we funded it using that one click. And then we just click on deploy contract, and then you see the transaction here. So this is also pending, of course, but as soon as this goes through, we have successfully deployed this example. So it's like a way to just introduce people to the smart contracts and deploy it with ease. And we have the same here, just CK app. I showed on that one already. So I can show some other things about the code, for example. So I can go through that here. So we have examples. That's the one we have here. So we can choose examples and run them. So how it has been set up is we have like directories. So this is like a chapter, and then we have here sections. So we have metadata. This is just something I created myself, like the structure. So we have introduction. We have a base, which is smart contract. And we have like a base folder here. We have smart contracts, which initialize all the base files for a smart contract. And then on top of that, we add specific code. So for example, if we go to the first example, you can see this code. So it only adds this code on top of the base in a specific directory you define here. So in this case, it's in the source directory. Then we also have metadata here. So if like a title, a type is like a playground or a unit test mode. So with unit test, you have to pass a test in order to succeed. So instead of I will show a tutorial. Instead of this run button and this terminal here, when we run it, it will, instead of the terminal, it will show if you've passed the test or not. But I don't have any unit test modes right now. And we have like focus items, highlighted items, and a command we have to run. So this is important. The focus is important because we want to only render the files that we need, just to make it easy for a newcomer as well. Like you only show the files that they need. And the highlighted item is the item we actually show here. So we show the code of that. So that's about that. So I've made like custom scripts in order to build everything. So I've like built examples, built tutorials. So I've also made a lot of changes to this code, also to load in the bases differently. For example, we can check that here. So now we only render, yeah, you probably don't know much about this right now, but we only render the name. So for example, it now says base, smart contract. It only renders the files that it needs for this specific tutorial. It also removes them when we switch to another one. That way we can keep the same web container instance alive and we don't have to do anything fancy there or reinitialize it, which takes a lot of time. I think so. The main thing I want to focus on right now is the for example, what I showed you, the 3-click deployment. I want to focus more on the interactivity, and make something like, for example, a leaderboard or challenges available that you have to pass. So for that, I can use the unit test mode, and then add some authentication on top of that, so we can maybe log in with your wallet, so you can have your public key link to the leaderboard, something like that. But the main thing I want to do next is this part. So just add more interactivity to everything, and add some gamification on top of it. I think that was about it, what I had to show here. So are there any questions?
Hey, so there's one in the chat from Rudrak. He asks, what about ZK programs and deploying smart contracts that use them?
What do you mean exactly? ZK programs and deploying smart contracts that use them? You can, if you mean that you want to deploy your own code on using the Mina Playground interface, or?
Yeah, I'm guessing, is it can you deploy something to the mainnet using the Mina Playground? I believe that is what he's asking, but Rudrak, please feel free to clarify. Can we write ZK programs with the interface?
Well, you can use the IDE and you can run and write basically everything you need in there. So that should be possible. I'm not sure if I support, but yeah, in the IDE it should be possible.
Awesome, thanks. And I think I had one. Is it possible to extend this IDE to other L2s or other environments which are on Mina? So like, because this is very O1JS and L1 directed. So do you have this, have you thought about this, or how hard this could be?
I did think about the IDE. There are some challenges. I think also another project is now working on specifically the IDE, so maybe I can check with them. I think it's Chain IDE, so maybe we can figure out something together. Because also the IDE is a lot of it's a lot of work also to support. So maybe I think the main benefit is when we add tooling, like for example, what I showed, the 3-click deployment. I think if we add things like that, it makes it really beneficial. But just the IDE is not really that beneficial. So that's why I'm also looking more into tooling right now and interactivity to provide more value to people.
Gotcha. I don't think there are any more questions in the chat. So thank you very much for coming on and giving us a presentation of what you've been working on. It has been awesome.
Yep.
Thanks, Anna. Right. So we move on to the second project of the day, that is ZKHS and Revel. Hey, guys. Can you guys hear me? You're on mute. Ronak, you're still on mute. think we're still trying to sort it out. It's not me, right? Um,
Hello.
No, I cannot hear neither. Oh, no.
Yeah, can you hear me now?
yeah, we can hear you. Go for it.
Yeah. Hi everyone. I am Ronak and I'm here to showcase my project Revel.tech. This project was part of the CK Ignite Cohort 2 program, and after completing that program successfully, I continue to enhance it as a part of the Navigators program. During this period, I split my efforts between this Revel.tech project and also GKHS. So I further polished the UI and introduced new features such as the search functionality, hashtags, and a section for top beats. And okay, so without further ado, let's me start with the demo. Uh, I think we have to stop sharing. Yeah, yeah, I had to share my screen again. Hopefully it's not an issue. Yeah. So this is the landing page of the platform, and on the top we have a banner section that will show the important auctions currently live on the platform. And there is also this top bids section, and it will be like a live feed that will show the top bids currently happening on the platform in real time. And okay, so as you can see, my wallet is already connected, and I can see all the NFTs I own using in this my NFTs tab. Uh, as you can see, these NFTs are already in a auction, and I can easily create new auctions from this page. Okay, so let's create one auction for this one. Uh, I can choose the types and parameters and create the auctions by signing a transaction using a wallet. So let's create a blind auction. And I have to sign the transaction using our wallet. And after the transaction is successful, we can view it in my options tab. So yeah, so as you can see, like the new option got created, and it should also appear in this banner section. Yeah, as you can see, and so let's place some bits. But first, I need to mint some test tokens. So, and as you can see, I already have some test tokens already minted, or I can mint some more using this button. Uh, yeah, yeah, and also to bid. So, as you can see, for example, this auction is a blind auction. So, to bid on this blind auction, we need to use the private balances. Uh, so we can deposit uh, uh, tokens from public balance to private balance using this wallet interface itself. For example, let's deposit some amount. Yeah. So the deposit is a two-step process similar to Tornado Cash. Uh, the first transaction adds a commitment hash to the tree, and then after waiting for some time, the front end will automatically fire a second transaction. Uh, Second transaction is similar to the withdrawal step in Tornado Cash, as it uses the Merkle witness to the earlier commitment and the nullifier has to prevent double spend. But unlike Tornado Cash, we get an encrypted balance at the end, which is like a UTXO and can be divided and spent partially. And for example, in this case, we will use it to place some blind bids. Let's here you can see that it's using our private balance to place the blind bids. And let's place something like and we can we can we can sign this transaction again. Yeah, you can see that this was successful. We so let's check. Yeah, you can see that our private balance got reduced. We can visit my bids section to access all the past and live bids. Let's go to this page. As you can see, like uh, I think this auction has 2 bids already, as and we can see that like I placed 2 bids for this auction, and like and uh, so here we need to click this reveal button when it's in the reveal phase, but currently these auctions are in the bidding phase. Or we can simply opt for this auto and reveal button, but this feature is not currently implemented. Uh, I am planning to use the Randow's time long encryption for this hopefully soon. In this blind fast price auction, the top bidders will receive the NFT and others will get the bid amount back when the when the auction ends. Yeah, so let's now quickly go over the future prospects of this project. Uh, hmm, yeah. So in the future, I plan to implement the NFT bridging between L1 and L2 completely, and hopefully at some point I will be able to deploy the protobit sequencer on a testnet, and and like and so and I overall I want to create a low cost place to facilitate NFT trading and auctions uh for better price discovery. Like after the bridges are implemented, like anyone can bridge any NFTs from Mina to my app chain, or like from Ethereum to Mina and then to this app chain, and like host auctions in a low cost way. Yeah, and okay, so that ends my part of the demo, and now I will hand over to Rudrak for his project ZKHS. Okay, yeah.
Hello everyone. I think I am visible. Hi all. So I am Rudra Patro and I'm super excited to show you my project ZKHS. I've been working on this project since the Navigator program began. The main objective was to play a game of chess in a fully verifiable and trustless way. To verify, we will need to encode all the chess logic into the ZK circuits. My first version mainly focused on proving valid chess moves and game state. Every game event is a transaction submitted on chain. I devised an encoding scheme. Sorry. I devised an encoding scheme to pack the entire game state into 2 fields, the white pieces and the black pieces. So players can play a game on chain only using zk transactions. The final game state will be stored on the chain forever. Next, we worked on a new architecture using zk programs to move the bulk of the computations off chain. The proofs are generated on the client side using web workers. To play the game, the players move the pieces and the worker generates a proof that the chess move is valid. The client then sends the proof over the network. Both clients will aggregate these proofs recursively so that by the end of the game, each client will have a proof of the entire game. Another benefit of this approach is that we can keep the individual moves private and only reveal the end state of the game. This is how the multiplayer works. We have used peer.js for P2P communication between the players. We also created a system to share game invites to match the two players. We also made a proxy key system so that the players don't need to sign on every move, and we use auto wallet only to provide a one-time consent. We also added a feature to store the elo rating on chain. We also use the custom tokens for doing that. We stored rating for each player as their balance, and on submitting a valid proof on chain, we update the rating. The elo rating calculations were challenging at first because they involved floating points and modular arithmetics. Finally, we used the Taylor series approximation of the elo rating formula to calculate the result. I hope you can watch this video. In this video, we can see that the PTP mode is in action. On the left, we copied the link and pasted it on the right tab. The players wait for the zcaps to compile, which should be done at any moment now. Then they can start playing chess like normal. Here we can see it's offering draw, and we won and lost over here. Okay. So in the third version, we used WebSockets for the communication. And we also have a matchmaker server that matches players with similar elo ratings. This server also handles the communication. In this way, we can easily implement features like live spectators. Now we'll show you a demo of the live web app. So this is the main page. I press play. Now I connect my auto wallet and I signed in the consent. Now I wait for the match to be found.
Sorry to interrupt, Rudrak, but I think maybe your screen isn't updating. We can just see the third version.
Hope it doesn't take. Okay, so I hope there is a problem with sharing my tab. So
Okay.
this is the main page. I press play and now I'm connected to auto wallet. Here I'm waiting for my opponent. The server randomly assigns me white or black here. Okay, match found. Now, currently we're using dummy proofs for the demo, so it's going to be fast. We need to wait for the both players to compile the contracts and then we generate a starting proof, which is all done. So now we can start playing. This is using the sockets. Yeah. Okay, so that's enough gameplay. Let's resign now. And the game has ended. And you can see I can submit the proof. Opponent has left the match. And the rating updated. So I can exit. So moving on to the future plans of the PPT is visible.
Yeah.
Moving on to future prospects, we are planning to experiment on variants of chess. For example, dimensional chess. The chess pieces can move into a different board visible only to you, hence becoming invisible to the opponent, but they still move according to the rules. Pieces can switch between boards to evade enemy strikes and execute unexpected assaults. Another idea is to create chess puzzles where the puzzle solvers get rewarded for providing valid proofs. The power of zero knowledge is truly amazing. To conclude, I want to thank the organizers of this fantastic program, Will, Yasin, Harish Gedia, and Gregor, for their constant support, without which this project would have been impossible. And also the Mina Navigators technical team for giving us the best smart contract and documentation awards. Thank you.
Well, thanks a lot for your presentations. There currently aren't any questions in the chat, but maybe I can ask you to speak a little bit about what the ZK-Chess architecture is. Are you mainly using the L1, or are you using an app chain for your logic? Rudrak, this could be for you. Oops, I think he may have disconnected from the desk.
Hello.
Oh, you still there? All right, cool.
Can you repeat the question? I was.
Sorry, yeah, I was asking, are you using, for your architecture, are you using L1 or are you using an app chain for ZK-Chess?
The smart contract is not currently deployed.
Right, but are you using the L1 or is it an app chain?
Yeah, the smart contract is not currently deployed, but we are like using the ZK programs from the local chain, and the program is entirely like on the client side. So at the end, we are thinking to deploy it like in the future prospects, and the reasons being like we have having like with the latest OneJS version of 1.1, there is a like compilation is doing the programs, but it's not running the functions. So we are waiting for that bugs to be fixed. Then we are trying to push it on the chain.
Okay.
Hello. Yeah, so the version 1, 2, and 3 all will be deployed on the Mina L1 itself. And in the future, we also have plans to make a fourth version, and we are hoping to use protokit for it. And yeah, so one drawback of the current architecture is liveness issue, because we cannot force timing on the off-chain computation. So we hope to achieve that using protokit in some of the future versions.
Gotcha.
Hopefully that answers it clearly.
Yes, thank you. And is there like any ability for two players to pause a game and return to it, or you need to finish it in one go? Ronak or Rudra? Are you guys there? I think there might be some technical issues.
Yeah, hello.
Hi.
Could you repeat the question?
Yeah, there are two questions. I'll ask mine first, and then there's another one from DFST. So the first question is, can you pause a game and recontinue later on?
Like pause I can.
Basically, you play half the game today and then go away and resume it tomorrow.
Yeah, we can do that.
Okay, good to know. And DFST is asking, how big is your contract now, and how long does it take to compile?
Like the realistic scales, like last time when it was working entirely, we are having like 200 seconds. Like,
Compilation.
and the methods are working like in 30 to 40 seconds for each. Like,
Each move. Awesome. So I think those are all the questions. Thank you very much for coming on. Sorry you were having technical difficulties, but it was really great to see the work you've done over the 6 months, and we look forward to seeing more progress. Thank you both. So we move on to the third presentation, and that is Mina announce. So Struct, all you.
Yes, thank you. Let me share my screen. Can you hear me?
We can hear you. We are waiting for your screen to come up.
Okay. Can you see my screen now?
Yes, we can see the presentation.
Okay. Today I would like to share my Navigator journey. I created two projects. One is the Mina puzzles, and another one is the Mina Aeons. And this is the agenda for today. I'll do a brief introduction about my journey in the Navigator program, and then I will use about 5 minutes to talk about Mina puzzles, and then for the rest of the time, I'll be talking about Mina Anon. There are a lot of interesting things to cover there. And then the last but not least, what I'm going to build for the future using these building blocks. So I started the program with from zero, with little knowledge about Mina and zero knowledge, but the flexibility of the program and also the learn to earn sessions have supported my journey really well. So I could learn and also experiment and also build along the way. And when I was getting started, I was wondering why. I started with why I should be building what I'm building. So I come from the business background, so I believe that the success of Mina would be that there are a lot of active users on the chain, and also see the value of Mina, zero knowledge, and other privacy capability. So I have always been thinking about how I could bring more users to Mina ecosystem, and how I can make Mina approachable and accessible. So with my first project for Mina puzzles, my main objective is to make Mina approachable through fun puzzles and games. We can see a lot of games and puzzles are built in the Navigator program. And then I started another project called Mina Aeons, really inspired by the release of ECDSA support, and I'm very inspired because the primitive and also the crypto gadget can be a game changer, which can catalyze a lot of interesting products or projects to be built. So So with Mina add-ons, my main objective is to bring Mina to other blockchain, Ethereum, other EVM chains, and as well as Bitcoin as a ZK enabler or a ZK layer. And a lot of people will be thinking that Mina is a L1 chain that is sitting in silo, but I see Mina as a zero knowledge layer or enabler that can be easily integrated into other blockchains and other applications. So with this project, I really want to showcase the power of Mina and show that it is really easy to be integrated into other chains. So let's get started with Mina puzzle. This is the landing page, and this is the repo of the source code. So from the landing page, we can check out the puzzles. Those are very simple puzzles. Those are very simple puzzles, and this is the GitHub repo of the project. I have written a lot of documentations and how these are designed, how the project can be run and deploy, and also some notes about the code. And also I included a lot of videos just to really show what this project is all about. So for Mina puzzles, I created 4 simple puzzles. And the highlight of all these puzzles are that these puzzles can be play right away, so that there's no need to wait for the compilations or deployment. And also, I use the Rome-oriented architecture. That is the typical design of JavaScript puzzles. So that we can host many puzzles and many players per deploy contract instead of deploying contract per each gameplay. So I recorded the demo. So the puzzle can be played right away, and when the solution is ready, then we create a proof and then submit it to the quiz game puzzle testing about the knowledge of Mina, and this is the Sudoku. Many puzzles can be hosted per a deploy contract, and the many players can come and play the puzzles, and their success will be recorded in the either market tree or the on chain using events. So the takeaway from this part of work is that I wrote a very comprehensive tutorial to get started until deploying the full stack ZK apps on the web on Verso. So this is the learning curve issue that I faced when I was starting from zero, learning from the existing tutorial, which focused a lot more on the contract side. But there's some gaps in the learning curve. So I created this tutorial to help the incoming Mina developer and welcome them into the ecosystem and help them launch the full stack ZK apps. So next, I created 2 peer-to-peer real-time games, simple games. mainly to test out about the recursive proof and how these proof can be passed around between two players on the front end. So I use the WebSocket and also store the game state in the Redis key value store. So player 1 and player 2 get matched in a room. They're basically sharing the WebSocket channel, subscribe to the channel, and then passing around the proof and also game chats. Here is the demo. So the game is loaded onto two different browsers. So generating the move proof. So the proof is passed on through the WebSocket to another player. Yeah, back and forth, and then the game is completed. So one key takeaway from this piece of work is that I have taken out the share code and make it into a P2P kit, which is a starter kit to build P2P real-time apps using recursive proof and WebSocket. So the other developers don't have to start from scratch and use the existing code base. So just clone it and then tweak three different parts, which is the ZK program proof logic, tweak the UI, and also tweak the game logic. So just by changing these three files, they can completely build a new P2P app with this P2P kit. And this is not just for games. It can be used to build other P2P apps, such as trading, swapping digital assets between two people using the recursive proof. Then the Mina Anons. This is inspired by the ECDSA support. The power of the primitive and also the gadget that can catalyze a lot of interesting projects. This is also inspired by the Ethereum Foundation's PSE projects. So Mina Anon in a way have some elements of different projects. Firstly, the Anon Club, and also the Bandata, which is to manage a group of anonymous membership, and also some elements of the Semaphore project, which is to facilitate anonymous actions or interactions. So this is the landing page of the Mina Anon. So Mina Anon has 3 steps. The first one is to sign your actions with the wallet or the public-private key pair, and the second step is to proof, and then post the proof onto IPFS, and this proof can be used for different purposes. So I created a different demo screens to showcase different elements of this project. You can go and test it out. So this is just to showcase the login with the wallet. There's also another demo to log in with the your Ethereum wallet. So I can sign the message. So after signing, then I can generate proof. Generate proof for ownership and proof of membership, and then later on post the proof to the IDFS for archival and purposes. And I'll show you the demo later. And here is the GitHub repo of the project, and I have written also very comprehensive documentations, and have included other README files, and my experiments and my thoughts behind this project, and also included all the different videos to showcase the different feature of the project, and the demo can be tested right away from these two websites. And let me briefly talk about the architecture of the Mina Anons. So this is a simplistic overview of the architecture. It has three different puzzle pieces. The very first piece is the support to verify different signature schemes in a provable way. So currently I have supported I added support for verifying the Ethereum signature as well as the Bitcoin signature. Later on, I'll be adding support for others authentication scheme, namely the OAuth 2.0 and the Web Auth. And then the second piece of the puzzle is the proof of address, proof of ownership, and the proof of membership. So with these proofs, then we can make the anonymous actions. This is where a lot of creativity can happen. These actions can be such as posting an anonymous message, posting a anonymous vote, or posting a anonymous reporting, such as for whistleblowing, and etc. So this is where a lot of interesting things can happen by collaborating with developers in the ecosystem. So all these building blocks are created in a modular way, and with the coverage with test coverage. So this is to prove the ownership of BIB 340 signature. This is to prove the ownership of the Ethereum or ECDSA public key, and this is to prove the ownership plus membership. So all these are created in a modular way, so that these code can be reused for different purposes by other developers. I have also included the documentations and detail on how these are designed. So Mina handshakes Ethereum. So this is built on the ECDSA support, but the ECDSA public key is not the same as the Ethereum address. The Ethereum address is actually derived from the ECDSA public key. So we need to prove that the public key, the Ethereum address can be derived from the public key which is derived from the signature submitted to this ZK program. And then with the proof of ownership of the public key, and with the proof of membership in the whitelist, or in the membership list, then we have the building block. We have the building block necessary to create interesting things. So this is the demo where you signing with the Ethereum wallet, and then generating the proof. So after the proof is generated, then we can post it onto the IPFS. So the proof is on the IPFS, and then the proof can be used for different purposes. So in this demo, the IPFS proof is used to post it onto Twitter. So this is to support anonymous posting of messages, as can be seen in other projects such as the Hey Anon project. This is a demo of how to manage the list of members. The members can be managed easily here, which is stored in a market tree, persisted on the level DB, and here we can get the market proof to be submitted to prove that a certain public Ethereum address is belong to the list, to prove the membership. So now let us move on to Mina handshake snapshot. So this is to really find really showcase how the previous building block, which is the Ethereum / ECDSA support, and then implement it in an existing project. So I found a great project called Snapshot. I think most of you have come across if you are active in the DAOs and the governance. This is a voting platform used by millions of members. So used by leading Ethereum project with millions of members, and it is used to organize the governance process of voting the proposals, etc. So this proof of concept is done to really showcase that the Mina can be integrated into existing applications. So this is the source code of these integrations, and here are some of the thinking behind how this integration is designed, and also why there needs to be a ZK voting. So there are two challenges in the open voting, which is to overcome the groupthink. So imagine Vitalik voting for something, and that can sway a lot of voters to follow him. It would be better if the voter can be independent and apply their own logic into voting. And another part is to overcome the cancel culture. So some of the influencer might be voting, and the community will be canceling him or her because of what he voted. So this is where zero knowledge voting can be very useful. So I studied the code base of Snapshot and see the entry points where I can integrate, and also find a way to do it minimally. So in the end, I decided on the current implementation, which is to generate the slip ID, which is issued by the Oracle, which is used as the anonymous identifier, and then from the UI, we can generate the vote proof, and then the vote proof is persisted on the archive on the IBFS, and the vote by proxy is submitted by the Oracle to the snapshot sequencer. So the snapshot sequencers will ingest the vote by proxy and verify and then count the vote. But with the support of vote slip ID, and it is used to prevent double voting, while still keeping the voter identity anonymous. So let me show the demo of how. Sorry, so connections. So this is similar to the previous process, but the only difference is that we are submitting the vote and the proposal ID, as well as the slip ID. So after the vote proof is generated, and then the proof is archived onto the IDFS, and then it is submitted to the snapshot ingester to count it, to verify and then count the vote. So the key takeaway here is that integrating Mina as a privacy layer, zero knowledge layer into other blockchain and other applications is not very difficult. It's simple, and now I have a proof of concept ready to talk to the snapshot development team and get the integration process started, and hopefully it will be deployed for use by various DAO for their governance. And then the last but not least, Mina Handshake Bitcoin. For this part, I built it on the foreign calf gadget, foreign calf of the SECP 256K1 calf, and created a custom verifications for BIP 340's signature. And just a fun fact, actually the Mina signature scheme is actually a derivative of the BIP 340 signature, and here I have documented different aspects between the BIP 340 signature versus the Mina signature scheme, and how they are different. Basically, they use a different calf, and they use a different hash. So this is the code for the verifying the Bitcoin signature, and I could do it easily because of all the existing gadgets available in the OpenJS. That is the wonderful part of the composability of Mina gadget or primitive. And so with the proof of ownership and proof of membership, I have the building block ready to showcase some of the possibilities. So then I found Noster. Noster is an interesting project. It's a decentralized social media layer for decentralized protocol. It is mainly and widely used by the Bitcoin ecosystem. It used the BIP 340 signature scheme. So this is the noser, and all the messages or anything pushed it onto the network is signed by the public-private key pair, and the public key pair is your identity. So this is the post of Mina Anon. This is a post of Mina Anon, and I have posted a proof proof for a proof and a post for an anonymous poster. Here's the demo. To post the message, enter the message and sign it, and then approve, and then generate a proof. When the proof is ready, and then post it onto IPFS. And then the proof can be used to share it back on the Noster. Okay. I'm really excited for this because Bitcoin ecosystem in the past 1.5 years has been very vibrant, and there's so much momentum in terms of new standards such as the BRC20 and other layer 2s happening around the ecosystem. And I see Mina as a potential programmability plus privacy plus zero knowledge layer on top of Bitcoin ecosystem. And that way we can leverage this momentum of Bitcoin ecosystem, provide the values, and really showcase what Mina is capable of, and onboard more users and developers into Mina ecosystem. So after I had shared about the building block on Twitter, I would like to give a shout out to Ilya, our fellow Mina Navigator. After he has seen my tweet, he actually try out an idea, which is to do an atomic swap between Mina and Bitcoin. So swapping between the token on Bitcoin and then the token on Mina protocol, cross chain. So that is very interesting, and he was able to get it running in a few hours after my share. So that is really interesting and also very encouraging, and I'll be keep working on this building block to actually support to add interesting value to Bitcoin ecosystem with the Mina capability. And I'm open to talk about ideas and collaborations. And last but not least, what is next? Going forward, I'll still be working on Mina Anons because there are more building blocks to be built, such as the complete support for BIP 340, as well as adding support for other authentication schemes such as the OAuth 2.0. With this support, we will be able to support the majority of the Web2 login system, such as like Google login, GitHub login, etc. And the another building block that I'm excited about is the passkey support, which is also known as the web authn, which is passwordless. It's a next generation's authentication scheme, which also rely on the cryptographic scheme, which also support the biometrics. So this is another building block that I was building for Mina Anons. And with these building blocks, I'll be building two projects. Firstly, the Mina ZK gates, which is to do the privacy preserving token gating. This is a very widely used, very popular use case for a lot of Web3 community to gate access to Discord, Telegram for private minting, and for exclusive merchandise through gated Shopify, etc. And the next is the Mina ZK Auth. It's a ZK power authentication for both Web 2 and Web 3. And I see that in a very near future, we will see the convergence of Web 2 and Web 3 coming together, and there will be a huge need for an authentication system that can work with the Web 3 as well as the Web 2. So, and I will run these projects as a startup. So I will get started with the support from Mina Navigators Season 2, and then find the product market fit as well as the revenue model, and then raise funding from the venture capital. I think the startups are the more sustainable model to keep working and to keep providing values to the user as well as the overall ecosystem. That is all, and I would welcome your questions.
Thanks a lot, Struct. Very impressive presentation. So if the audience has some questions, please put them in the chat. Well, I might ask you, is there any particular primitive you are kind of waiting to be to unlock you? Like I could understand once CCDSA was added to O1JS, you could build so much stuff. So is there something on your wish list to take you from level 20 to level?
Yeah, I think in terms of the underlying primitive and also the support with the foreign card and also the gadget and also the recent improvement in the bikes level primitive, I think it actually opened up a lot of interesting potential. So one thing that I'm really excited is the P256, which the passkey authentication system use. So with P256 support, which I think I will be building myself. so I'm really excited for this because that offer a huge user experience improvement, and we don't need password anymore. We can use the biometrics, and also it's supported by web browser as well as the different devices. Yeah. Excellent. So that is interesting to onboard the next billions of users onto blockchain. Yeah.
Excellent. Thank you. There aren't any more questions, so I wanted to thank you for coming online and giving us a tour of everything you've been building over the last 6 months.
Yeah.
So thank you, Struct. And
thank you, Harish, and also the Mina Navigator team. You have been really supportive. I can share about my story later on. I'm really grateful for designing this kind of onboarding flow for new developers, completely new developers like me. So that is really encouraging. Yeah, thank you.
Very, very happy to have you. Thank you. So we can move on to the next presentation of the day. And Varun, if you're online, you can grab and play the video. And if you do have any questions from the audience, please put them in the chat, and Varun will be online to answer them for you. So Varun, please go ahead. Varun, can you hear me? Oh, yeah.
Okay, do you hear me?
We can hear you. Yes, we can see your screen is being shared now.
Pushing at the boundary of zero knowledge application on Mina protocol. Afternoon, everyone. I'm excited to be there today. Present our work on CK, Oracle, OCO, and Open Nautilus, two open source projects that are pushing at the boundary of zero knowledge application on Mina protocol. As you can see, CK, Oracle, OCO was recently recognized within the Mina ecosystem for its best reuse of modular code. We will explore how we achieve this, along with the exciting progress we have made on both projects. Let's start by diving into one of the fundamental challenges facing CK application on Mina, the Oracle problem. As we dive into the world of zero knowledge application on Mina, we encounter a critical hurdle, the Oracle challenge. Traditional Oracle on Mina grapple with two key issues: efficiency event fetching from the blockchain, accessing reference data from the blockchain in a timely manner is offer a bottleneck. And second, management of Oracle contact. The complexity of maintaining and permission Oracle contact can be a significant burden for developers. The consequences of that challenge are far-reaching. They directly limit our ability to build sophisticated CK applications that rely on external data. This impacts a wide range of possibility applications, including real-time price feeds for DeFi applications. Our goal with CK, Oracle, OCO, and Open Nautilus is to become that limitation and unlock the full potential of CK application on Mina. By tackling the Oracle challenge head on, we pave the way for a new generation of decentralized application that can more powerful and reliable. Drawing inspiration from the CK, Oracle, OC, OFW off-chain worker concept, CK, Oracle, OCO introduced a modular and innovative approach to Oracle solution on Mina. At this core, CK, Oracle, OCO bring two key innovation. Dedicate backend disk efficiency backend tackle the challenge of fetching block event directly from the Mina archive node. By streamlining this process, we ensure the Oracle data is readily available for CK application. And smart contract suite. We have developed a comprehensive suite of smart contracts that simplify the entry cycle of Oracle contact from creation and development to manage and update. also provide a tool you need to seamlessly integrate Oracle into your application. We expand the horizon of what's possible with CK Oracle OCO with ERC 677 support. We are actively developed at the support of ERC 677 transfer, which will unlock the potential for ever more sophisticated and data-intensive Oracle model. This opens the door to applications like machine learning or advanced analytics and more. Let's dive into the internal working of CK Oracle OCO and see how it orchestrates the Oracle data flow. View Oracle request. This initiate step involve constructive well-formed Oracle request. This request encapsulated the specs data that the CK app needs, such as data type, source, and any relevant parameter. Sends Oracle request. Once the request is built, it's sent to the Oracle CK Oracle OCO backend. The backend acts as an intermediary handle communication between the CK application and the blockchain. Third, sync data. The CK Oracle OCO backend interact with Mina blockchain to fetch the requested data. It may accept heuristic data from archive node and real-time data from node, depend on the nature of the request. 4. Fulfill Oracle request. After retrieving the data, the backend process is and prepare it for delivery to the CK application. This may involve data validation, formatting, or aggregation. 5. Fulfill request. Finally, the CK Oracle OCO backend securely delivery to fulfill Oracle request to the CK application. The CK application can just utilize dash verify and translate data to a slot. Now, we introduce the Open Nautilus. To explore how the CK Oracle OCO revolution Oracle data on Mina, let's shift our focus to Open Nautilus. The powerful toolkit designed to simplify and accelerate CK application development. The core goal of Open Nautilus is to make CK application development on Mina more accessibility and efficiency. We recognize the exciting tool like O1JS can pose challenge, especially when it comes to contract creation. This being asked to make innovative behind the Open Nautilus is a contract builder. We were inspired by frameworks like Open Sprint and on Ethereum, which allow developers to create complex token contact with else. We saw needs for similar capability of Mina when O1JS was missed in the regard. We built the Open Nautilus contact builder from the ground up. It provides a streamlined initiative interface for creation and deploying token contact with customized stable parameter that like you would work with Open Sprint. This is significant to reduce complexity and borrower padding code developer need to write. It offers a comprehensive suite of the features to empower CK application developer. Abstraction and tool for CK application logic. We have to create a library and abstraction that simplify common CK application pattern, reducing the amount of custom code you need to write. Now we support ERC20 and ERC677. We cover the most popular token standard as well as provide flexibility for creating your own. And we integrating protobuf message. Is a Google protobuf for data stabilizing data and transfer between CK application on the blockchain. With Open Nautilus, developer can finally focus their time and energy on the core logic of their application, rather than getting down in the low-level cost of complexity. Now, 6-month progress timeline. We have to make remarkable progress in just a few short months. Thanks in the part of the support of the Mina Navigator program. This timeline showcases our key milestones since joining the program last October. In October, we kicked off by joining the Mina Navigator program and submit our project proposal. This marked the start and an exciting journey toward bringing CK, Oracle, OCO, and Open Nautilus to life. December, we had to success develop the Open Nautilus token builder and crucial component that streamline token creation for CK application. We also began testing development on the Linet, granting valuable insight into the real-world performance of our tool. January, our momentum continued. We implement ERC20 and ERC677 token builder integrated protocol for efficiency data handle and start to explore possibility of Oracle request using protobuf. February this month saw us deep into the integration between CK, Oracle, OCO, and Open Nautilus. We successfully integrated Oracle request functionality with event fetching from the blockchain, enabling seamless data retrieval for CK application. March, a major milestone rushing in the March as we integrated ERC677 transfer and call functionality directly into our Oracle contact. This allows a new possibility for more complexity, Oracle interaction, and data transfer. April and lessons. We launched our comprehensive document site built from TS document comment into our code. This resource empowered development to quickly to start with delivery the full compatibility of Open Nautilus. Deep inside the library, Open Nautilus use the token builder. The slide encapsulates one of our most significant achievements with Open Nautilus. The token builder, as can you see from this slide, creating an ERC token on Mina is now as simple as a few lines of code. Contract creation, this is the way the magic happens with the simple call. Build ERC20 contract. We create a fully functional ERC20 smart contract and for which you provide address, token name, symbol, and decimal. This object can use to deploy. Next slide, insulate. Step 2, integrate our Open Nautilus specific and with Oracle contact in the Mina. This step set up the ERC token and Oracle address. And step 2, build a path further mission with RS. The previous slide, we now dive into the heart of Oracle Interact. Build the Oracle request, specific, transfer, and call function. Oracle request object provide the information to populate with the detail. In this example, protocol is specified the HTTP method is a get method, and URL which you want to request we use a crypto compact to fetch the Mina price in the USD and call the build transfer and call transaction. This step is a fetch event, fetching and reconstruct that Oracle data within the Open Nautilus framework is highlight the intricate process of retrieve raw data from the blockchain, parsing it and transform it into usable format for CK application. First, refreshing event, and second, we parsing and extract the event to the Oracle request in the protocol format, protobuf format. This step is the option process. We use the data from the request and use the fetch API to retrieve price This step is fulfill Oracle request. This slide divides into the final step to fulfillment of Oracle request. The first step beside the feed data and signature request use the private key of CK and cross the slide and fill to fulfill the Oracle request. Okay. Yes. Okay. This demo about request to the PTC and okay, finished. Okay. Thanks you for joining us on this channel in the world of CK, zero knowledge application on Mina. We have covered a lot of ground today. Thank you for time and attention. We're excited to see you how to create what you create with Open Nautilus.
Thank you very much, Varun, for the lovely presentation. If the audience has questions, please put them in the chat. and Varun will answer them for you. I hope you have a lovely day. We now move to the next presentation of the day, and that is from Tokenized ZK Finance. So if you're online, please, the stage is yours. Hey, Yoga. You are on mute, Yoga, sorry. Yoga, you're still on mute. We cannot hear you. Yoga, I think you need to go off mute. You're silent. We cannot hear your voice.
Hello,
Yes, we can. How are you?
everyone. My name is Yoga. Since our team English level is not very good, therefore our team provide a mental co-star to help us introduce the tokenistic finance project.
Hey, hello, it's my pleasure, Yoga. Okay, hi everybody. Now, since I am the member of tokenicity finance team in ZK9 Core 2, so I'm familiar with the technical architecture and solutions of the project. So, of course, my English is a little bit better than the teams. So they asked me to help them. Yeah. Okay. Now let's begin. And during my presentation, you can interrupt me by any questions, and I think I can answer 80% questions. And the other questions that I cannot answer, I will help you translate to Yoga, and I will act on as the translator. Okay, let's begin. Can you see my screen? It is a PowerPoint.
Yes, it just came up. We can see the slides.
Okay. Okay. Let's go on. And okay, this project is I will speak in first person because Yoga gives the speech script to me and he write it by first person. So I will speak it by first person as first person. Okay. So our project name is tokenistic.finance. It is the first verifiable long page on Mina with no code. Our background is that, well, as we know, ERC style token have greatly contributed to the prosperity of the Ethereum ecosystem by providing a flexible way to create a custom digital assets and then facilitating application development, improving liquidity and interoperability. According to statistics, there are an significant number of users and teams who want to issue their own tokens. However, issuing a secure and fully custom token is difficult for people without enough knowledge on programming and cryptographic background. The pain point motivates the birth of many popular online tools or platforms, providing convenient flow for people to create or sell an author list on DEX, their custom token, which boosts the on-chain ecosystem. Samely, custom token on Mina matters much to the ecosystem, especially custom token is designed as an underlying native property on Mina chain, which hold similar capabilities as ERC style fungible token and natively works with zero knowledge proof, further meaning it could be more easily used within privacy preserving scenarios. However, the development in an interacting pattern of Mina's natively supporting custom token performs distinctly differently with the ERC style fungible tokens. Besides, the knowledge or zero knowledge proof is a little bit more complex, difficult than the solidity layer contract. Therefore, a suite of tools is necessary to help the common users create their own tokens in a fast, simple, and cheap ways. With no prior knowledge on code and zero knowledge proof required, and 100% decentralization. Decentralized. And tokenistic.finance, it is such a verifiable platform, verifiable launchpad where you could launch your own ZK token and create your own initial token sale. It provides secure smart contract templates with flexible configuration and complete tool suites for token management, where you could finish all operations simply in several clicks without knowledge requirement about code and zero knowledge proof. Let's go on next page. And besides, tokenistic.finance is a funded project in ZK Ignite Cohort 2, and it is also the first launchpad running on Berkeley, and now it is deployed on DevNet. And during the Navigator program, 6 months, we have achieved these features. I will first ZK token creation and normal sale, fair pre-sale, private sale, fair airdrop, and also after 3 months, within the last 3 months, we also carry out the only widget and also the project common module, project statistic, and also we provide outsourced computing service. Okay, now to here, let's go on a review on our product. Could you see my screen on the official website?
Yes.
Okay, and this is the official website, and you could see all the features we carry out during the last 6 months: pre-sale, fair sale, private sale, and the airdrop, and also the creation entry for all the features. Okay, and just wait a second. And this is I will introduce the page and let you all to glance at the page, but I did not click the button to officially create because this operation will cost much time. So in advance we prepare some videos, and then we could go faster on the video to show how we features works. For example, this is the ZK token create page. You could enter the basic information on the page and click create, and then you will trigger the circuit, go into the circuit witness, and also the proof generation and the deployment. I switch to the video. Okay. Just wait a second. Sorry. Did you see my video? Sorry.
So it's showing the tokenized ZK landing page. Yeah, it's a video. Sorry. Yeah, it is. Yeah, I think I can
Yes.
see.
Okay. Let's go on.
Yep.
Okay. This is the video for create ZK token. Let's go faster. Okay, now witness calculating. Let's go on faster. Okay. At this section, I have to explain that the underlying mechanism is that the main thread render the UI, and we make usage of the worker thread to go on the witness calculating, and then pass the proof and transaction back to the main thread and trigger the auto wallet to send the transaction. Okay, now the transaction was sent. You could see it in Mina scan. Pending. At this section, we need to wait. Okay, now the token is creating. And then we could go on create the pre-sale, fair sale, and the airdrop. Now is is about the flow of pre-sale. As you can see, when after you create the ZK token, then you could, based on the token, to go on create the pre-sale. When you connect your wallet, you could see all the ZK token you created before, and based on it to create pre-sale. There is a fee option. Okay, let's enter the basic parameters of our cell. For example, soft cat, hard cat. These are the parameters you could configure to your cell. These parameters act as the rules. You could see that there is a whitelist input. The whitelist input will, if you fill in the whitelist, then it will calculate the Merkle tree root locally and store the read, and the root will be stored on chain into the cell contract, which will be used to check membership. And these are the vesting parameters, which means, for example, at this screen, which means you could, after 3 slots, about 9 minutes, half of the tokens you got will be released, and then after that, you will got 25% token after 5 slots. This is the knowledge. This utilize the vesting mechanism of the Mina tree. Okay, let's go on filling some cell info. For example, your logo, your website, Facebook, Twitter, and so on. So go faster. Okay, let's go on. And these are, and here's the review step, reviewer page, to let you review whether the parameter is aligned with what you think, what you want. Here's the whitelist. We will check all the public keys underlying, so please don't worry. Okay, at this section, the cell's address will be generated automatically. Okay, now we enter the stage about witness calculating. Let's go on faster. Okay, now the transaction was generated. Okay, the transaction was sent. And when the transaction is confirmed, then you could enter the detail page. The detail page will present to the common users who are interested in your cells. And okay, now these are the steps of creating pre-sale. Okay. Okay, and now we go on contribution. When you are interested in one token, that then you could copy the token by contribution into the cell. For example, before the cell ending, you could participate. Okay, you enter to Mina and click the contribute buy with Mina. And then we'll go on proof generating. Okay, the transaction was generated. Now the transaction is in the memory pool and its status is pending. Let's go on faster. Please focus on this block. When the transaction was conferred on chain, then now you could see that you have the page will prompt that you have contributed to Mina. Just wait a second. Okay, the transaction is confirmed. Okay, these are the steps for for cell contribution. And and then let's go on next step. After we contribution, we could claim the token. But there is a explanation now here, because their team, TokenSK team, just upgrade their OpenJS version to 1.1.1.0, and they meet a special question, a special issue that leading to the steps on claiming token prompt error. So we are asking help in the community. This is not related to tokenization. Maybe so I don't know if it is a potential bug or others about OpenJS, but we are asking for help. So we skip the steps on claiming token and go on redeem funds. Redeem fund means that when the When the cell ends, however, the softcat does not meet, then which means that this cell failed. So every user who contributing should claim to redeem their funds back. These are the videos show this. Okay, please look at here. When the cell ends, that the softcat does not meet, and you could see the button to help for you to redeem your funds. Okay, at this section, we have at this section I have to explain that since to keep security, our contract need consider the risk about that some evil user might redeem their funds for many times. So underlying in a token, we will make some make some we'll make some mechanism to avoid the risk. For example, we utilize nullify key to check non-membership, and that we could avoid some risk about double redeem or double claim, which are similar to double spend. We have to avoid the risk. And this is why we have to deploy the redeem account circuit on the screen. The redeem account will be deployed to the user's Mina account. Now it is deploying. Okay, the transaction is sent. Let's go on faster. Okay, after the redeem account deployment, and then we could go on redeem your funds. Okay. Let's go faster. This transaction is go redeem funds. It seems that the video some issue. It cannot play. I don't know why. Just wait a second.
Sure. You can also upload these to YouTube and we can include them.
You mean upload the video to YouTube?
Yeah, if we cannot play it, you can put all these four and we can link them.
Okay. Let's click the progress to go on. Please look at here. When the transaction was confirmed, that you could see that the page will prompt that you have redeemed to Mina. Please look at here at this block. This block. Okay, now is the flow about redeem funds. All the steps you could experience on our website. And we, because to avoid wasting time, we don't present the flows on create private sale, fair sale, and airdrop, and others, because they are similar, but their parameters and the lures are different. You could go to experience. And let's go on. And after last 3 months, we go on carry out the only widget and common and the statistic module and outsourcing computing service. Oops. Okay, this is the only budget. Only budget, so here. Oh, maybe the network is fetch account. Maybe the third-party GraphQL is unstable now. You can see that when you claim your token within a cell, and then you could manage your token here. For example, choose this token and then we'll fetch the real-time balance on chain, and then you enter the receiver and the amount and then create. And besides, we will record, we will help you record the token transfer history regarding specific token. Then you could you don't need to go to Mina Chain Explorer to find out your transaction. So we think this is a good user experience. Okay. Let's go on. And we also add common module and statistic module, and also the outsourced computing service. Let's go on. Let's choose one cell and enter. For example, we add this module to let user to comment. And then this is a method we think for users to know more about, to know more knowledge from all parties. each command will be asked for a signature to avoid some attack. Okay, now it is on here. And also we also provide some metric statistic graph to present to present how many tokens are distributed and how many are rest. Please look at here. Now it is 100%, which means it meet all the contributed Mina amount is meet the hard cap. Now you can see that all the token will be distributed. Six Mina. The custom token based on the custom token corresponding to 6 Mina will be is distributed. Okay, and now go on outsource computing. As we know, ZKP costs much time on the witness calculating and cost much memory resource, CPU resource, and others. So we regarding this, we provide a service about we need outsource computing service, which means that when you contribute it, when you collect token, when you redeem your funds, actually we will forward the proof generating request to our backend cloud, and we will help you witness calculating and generate proof, and then you could fetch back the final transaction and sign. This could help user with not good devices and experience more smoother. I think this is because tokenicity is not related to privacy, so people could send their proof generating request to cloud for outsource computing. Okay, let's go on. This is the architecture design. As you can see that we tokenicity is based on a token factory. The token factory which will stores the matter info of the whole platform. It will, for example, for example, the platform owner could configure the fee for create token, create sale, and this is the revenue source of tokenicity team. And let's go on. Token factory could deploy, create, and deploy airdrop, and the sale and airdrop. Each operation of the sale and airdrop will be authorized by the relating ZK token, and this user account is used for as a token is as a token holder, and as well as a redeem account. I just said to avoid double claim, double redeem. And now I'm here, and here is the note that you don't need to remember all the token key, sell key, and airdrop key, because they are all derived from your wallet, your Olo wallet. So This is convenient. This make user experience good, experience well on, because they don't need to remember anything related to the to the generated token sale and airdrop. Okay, and this is the high level architecture. It explained what I said just now. For example, this is the tokenistic web client. This is the Mina chain, and then we have a core service to maintain all the Merkle trees. And proof gen service is what I said just now about outsource, about a cloud for outsource computation service. The core service will monitor the chain and then maintain all the Merkle trees and maintain all the Merkle trees into the contract to keep consistency. Okay, this is our storage design. For example, the whitelist you see in the video is by whitelist G, and when all the user contribute, the cell, then they will record into contributor G and this will be utilized to check membership. And this is the user notified G. The root will store at user account to avoid double claim, double redeem. And we also make usage MySQL to store some basic information of tokenistic of token owners or cell owner team. And then we also utilize Mina chain to store all the information. For example, when you contribute a sale or claim or redeem a fund, this will be stored as action or event on chain, which means that you could rebuild all the off-chain state anytime based on the event and action. So you don't need to be worried about tokenistic team because all are stored on chain and could be verified. You could rebuild all the trees anytime. This is our mechanism on data availability. Okay, and now is about the security and performance page. You could see that during my presentation just now, I talk about the I talk about the key derivation and about the mechanism to avoid double spend, to avoid double claim, double redeem, and these are the mechanism. These are the mechanism for us to keep the security for users. And the data availability is what I said just now on this page. Merkle tree and action and event, you could build anytime. And a computation outsource service to help people to accelerate the ZKP generation. And then we also have enhanced our backend server to improve our performance, like microservice, like low balance, and many practice. Okay, now this is the long-term vision. Just wait a second. Okay. We all trust zero knowledge proof matters much in the coming future, where we could easily foresee that tokens with zero knowledge proof capabilities must play an important role wherein. Furthermore, this is why we carry out such a launchpad platform. We now focus on custom token on Mina chain mainly. And furthermore, as a platform that supports issuing and selling tokens, tokenistic vision for future development resolves around creating a safe and efficient ecosystem for token issuance and sale. The platform aims to provide a user-friendly experience for token issuers and investors while prioritizing transparency and trust. Therefore, respecting future development route is as follows. First, we want to be a platform where anyone could issue and sell token. We provide user-friendly interface that enables individuals and business to create and sell their own token. And we also want to be a platform to popularize ZK token and a project incubation and brand building platform. In addition to token issuance, our platform also serves as an comprehensive ecosystem for project incubation and brand building. We provide resources, mentoring, and networking opportunities to help startups turn their ideas into successful business. Through mentorship programs, funding access, and strategic partnerships, we aim to nurture promising projects and foster their growth. In addition, our platform provides tools and strategies for brand building, enabling projects to build a strong market presence and interact effectively with their target audience. And we also want to act as a bridge between ordinary investors and VC. Yes, the 4 points are mainly our tokenistic team's long-term vision. And this is about our business model. And at current stage, we provide a token launch board service where projects can conduct the initial token offering. Tokenistic platform will charge a fees for all services. For example, token issuance, cell deployment, and and airdrop deployment and any related service, we will charge some fee to maintain our team to go on. And also we provide outsourced computing services. We also could charge some fee, and we also could develop more templates to, for example, some high-level templates that we could help users to customize their own templates, and this could be an avenue resource. And in the future, we expecting to provide services like listing on DEX. But as we know, DEX or Mina currently is not mature, so we are waiting for some decentralized exchange to come out, and we are seeking for some partnership, cooperation. And we also expect to provide some operation service. And these overall tokenistic case business model revolves around providing a comprehensive platform for token issuance, token sale, token listing, and contribution, establishing itself as a leader in the digital asset space through a variety of convenient services. Okay, that's all.
All right. So sorry, please, if you want to finish. All right. So thank you very much, Gold Star and Yoga, to come online and share the work which you've been doing over the Navigator's journey. We are slightly over time, so if the audience has any questions, I request them to please put them in the chat, and hopefully the two of you can help answer them. So thank you again, and I would like to invite the last team for the day, which is ZK Database. So if you are online, please come forward, and obviously you have another 10 minutes added on to do your presentation. Thank you.
Thank you.
Oh, thank you. Thank you.
Hi, everyone. I'm Chiro, founder and CTO of Origin Network. Origin Network is a company that do research in cryptography and zero knowledge proof. We also do research in MPC and how we can utilize zero knowledge proof and cryptography to build the infrastructure for Web3. So today I bring to you the ZK Database, a project of Origin Network. And this project, actually, we are the participate in the ZK Ignite cohort 1. And also, I and Ole also joined to the Mina Navigator program. Okay, so let's see about the current state of data availability layer, of Mina protocol. When people say something like they want to build the ZK app, actually they need to implement and handle the storage on their own. Even O1GS provide the Merkle tree commitment and also provide maybe like some sort of distributed storage out there, but then there is no complete solution that handle the the data availability. So let's take a look in the detail. So just as you see in the tokenized project, like people have a lot of issue with data availability, and also they have to do the Merkle tree commitment themselves. And every project, every ZK application, they need to implement their own solution. So in the long term, it's not a good way. Besides that, every project, when they do like they draw up, they do their own solution, they draw out their own solution. They have a problem with the scalability and also the performance. For example, when you do IPFS and use the IPFS at the storage, you will take a long time to get the data from IPFS. And in terms of performance, right now, if you do the client-side proving, it took a lot of time for you to generate proof because the browser, it cannot utilize the GPU or hardware acceleration, and it have the limits to access to the hardware resource. And then you see here, we are building some sort of infrastructure for Web3 and also building product for Web3. But then we are living in the Web2 reality, and user and every people and every business and enterprise, people still thinking in the Web2. How we can overcome that? And how we can use the ZK database and provide the ZK database for Web2 people as well, and onboarding them to Web3. So we are in the very early stage of development, like building the ZK app. People do not have idea about how ZK app going to be built before. But then now with Mina protocol, everything much more clear, and also there are a lot of documents and also the assemble for O1GS that people can try and build their own ZK app. So I think like ZK database gonna provide the better toolkits that allow people to implement and focus on develop their own solution, implement their own business without care about all complex stuff about data. And then there are a huge problem with authorization. Right now, we don't have the standard for Web3 authorization, and also a standards allow people to implement decentralized identity. That's why we thinking like how we can bring up a solution for all of the problem. So I will walk you through our proposal, architecture, and also the current implementation. Besides that, I will pick some application of the project that can some section that actually like ZK database can help people to improve it, and also the future of ZK database, ZK modular data availability layer. Okay, so the first thing I want to bring to people is how we can make everything very clear for people to use and see. Right now, like every project, they handle the data availability themselves. That's why they no tool for them to manage the database, and they cannot visualize everything about the data. So we think that we provide not just smart contract or a package for developer, but also we provide the ZK database management tool, allow people to explore data and also control their ZK database instance. So our proposal include ZK database in serverless fashion, and also we provide the Zk database as a service. So everyone with Mina protocol token, they can create their own Zk database instance and integrate with our solution. We create the proving service, allow people to outsource the proof generation to the server side without without harm to the correctness, and also without harm to the completeness of the zero knowledge proof. Besides that, we provide the SDK, allow the developer to integrate with their ZK app, and just a few steps that like install the buckets, and also they can start development. And we build everything in the ODM fashion. So everything will look similar to MongoDB, but then you can generate the zero knowledge proof whenever you want to prove the context of the ZK database on the smart contract on Mina protocol. We also provide a graphical user interface, allow people to interact with the database. So let's take a look into our architecture. As you see here, we simplify our architecture in several components. So at the user land, people can use the web UI of the ZK application to interact with the ZK app. So inside of that, we have the ZK SDK building on top of O1GS, and people can actually like just interact with the ZK database SDK to allow them to get the proof from the ZK database, and also query for the witness, Merkle root witness, or outsource the proving, or do the data run up. So people who develop the ZK app, they can focus on implement their own business and let us handle everything about data for them. ZK database service, other service, they provide several components as you see here. The GraphQL endpoint allow people to interact with the ZK database, and also retrieve the data, and also handle everything like authorization. We allow people to authorize with their own digital signature. So just very simple. You open the web UI and you using the ZK app, then the wallet's going to pop up and allow you to sign a message. So that signature going to be validated on the server. So, and also we manage the permission, allow people to share the data that they want to share, and also like they can cover the data they don't want to share with other people. We build the same permission system, looks similar to Unix, so people can quite familiar with that concept. The next component is commitment scheme. Right now, we just submit, support the Merkle tree commitment, but then in the future, let's think about like maybe KGG commitment and also Merkle tree commitment. Right now, we already implement this in another project, but it implement on Halo 2. So in the future, we want to bring it to the Kimchi proof system as well. And from that, I hope that we can benefit the Mina protocol ecosystem. And beside, we have this the scheduler. So the scheduler going to like everything work like this. every time user do something like they update information, update the database records, they're going to do the database transaction, and then we're going to batching them and bundle them and do the data run-up. So at the end, we're going to schedule and push the data run-up to the data run-up service. So with the Mina protocol recursion proof, we can bundle a lot of data update in one single proof. And then at the end, we can provide that proof and also provide that proof for users. So they can submit the proof to the smart contract and actually like update the on-chain commitment. Right now, the Zkdatabase management tool already under development, and we complete like around like 50% of the product, the management tool. So I hope that we can provide it for really soon, and people can try out the whole product and have the same experience when they work with traditional database. So at the bottom here, you see the MongoDB Atlas cluster. So we use this to store the data and also use this as the data availability to provide the data availability. So some people told us that why we don't use the distributed storage, but then when we try with distributed storage, so we have to trade off the performance and also the latency for the decentralization. But then there's the big problem, like every ZK app may not usable because like experience with IPFS and also Filecoin is quite poor right now. Like everything is quite slow, and also every time we develop with the peer-to-peer, there's some problem come up, and then so I think in this day we just focus on how we can improve the usability for every people. So let's take a look in our implementation. So unlike other project, we actually like do research and also document everything about Zkdatabase in our document repo. So you can see everything here, like how we do accumulation, how we implement B-tree and generate the proof of lookup something. For example, like we call it like lookup prover. So you prove the existing of one record somewhere in the B-tree and how we look up that. And we also provide the formats for data, how we deserialize the data and store it on database. So there are a lot of stuff that we already implement from this document, and also explain how we benefit from this approach. So I hope that all the team, they can look into our document as a case study in case they want to build something similar or learn something from our own project. Okay, so every short goes, so here Ole, he worked with me. So I and him together, we are co-author of Zkdatabase, and we already developed for quite a long time. So right now you can see the structure of the project. We have an example, you can try it. And also we have the packet here that contain everything, like the Zkdatabase SDK, the storage, the serverless, the proof service. So the portal is actually like the Zkdatabase management tool. Kubo is the live client to interactive with the IPFS nodes. And then I will walk you through what we have here. So the first, we already implement In the ZK Ignite, in the cohort 1, we actually like explore the potential of O1GS library, and also we want to see what is the limit of O1GS. So we implement the first version of ZK database, and it's utilize IPFS, and we got around like 3,000 downloads. So we still see the problem with our product. That's why we joined the Mina Navigator, and we solve the problem with the ZK database as a service. So we allow people to log in and also sign up with their digital signature. We implement the unique like permission system. Besides of that, we implement data run-up scheduler and the ZK database management tool, a web-based application allow people to manage their database instance and also do a lot of stuff like checking for the correctness of the Merkle proof and visualize the database. We implement the spare Merkle tree. So to guarantee the data integrity, we implement the data run-up service to maximize the efficiency when we do the on-chain verification. So with the advantage of like the Kimchi proof system and O1GS, we actually can bundle a lot of transactions. Right now, the ZK database SDK already available to you, and we hope that people can try from now, and we going to roll out many more examples so you guys can take a look. Besides everything that we have here, we build up the GraphQL interface, allow everyone to interactive with our product. If you don't want to use our SDK or you don't want to use the management tool, or you can build your own management tool. So here, maybe the very first application that I can, like the use case that you can utilize ZK database, the first thing, auditable finance. Like, let's think like people have a lot of product and about finance, and they want to do the audits. So the cost is quite huge to like do the audit in every records. That's why if you use the ZK database and allow people to input the data into the ZK database, we can actually generate the proof that's going to tell you that your database is correct, or every computation on your database is was done properly. So beside of that, I think like for a lot of people talk about ZKML, but then they won't tell you how they train their model or where the data come from to train the model. We can provide the Z data for ZKML and also include our proof of correctness of data in their ZKML proof to tell the people that everything from the input and also the algorithm and the module is correct and the training process is correct. And I hope that we can provide for ZK database for every project that we have right now and already like developing on Mina protocol. But the last one maybe like provide the data for on-chain gaming. I have this question from a lot of people from Web3 game. They want to store a lot of game item and stuff, but then right now they no such of solution that can handle that. So let me share with you the demo. Do you hear it well?
Yeah, we can hear you, Chiro.
I think like OLED recorded video, so I'm not sure.
If you play it, maybe I think it's not playing. So no, unfortunately, I cannot hear the voice on top.
Okay, so as you see here, like we have the proof service. Proof service will going to handle the data processing, but then, for example, like when you working with Zk database, there are a lot of database input and output, but then whenever you do something like you update the records, you insert new records, or you remove something, we're going to generate the witness for that step. But then whenever you wanted to generate the proof that available on chain, so we're going to trigger the proof service to generate the proof for you that bundle everything. And in this context, we have the GraphQL endpoint, allow people to interact with their own database instance. So you can almost do everything with this endpoint. Okay, so we define our own like structure for the data or every collection of the Zk database. So people can define everything, like define an account. In this example, we define some sort of maybe some, I call it like piggy bank, allow people to have an account in the bank and also do transaction to transfer the money or transfer coin between people. This is very like simple example, and how we can use this to build some sort of like even the token, we can implement it. So here we're going to create a ZK database storage. So the ZK database storage going to utilize the, and connect to the SDK and connect to the server side. So every time you do something interactive with database, the local instance is going to update your record on the server. And here you're going to sign with your private key. You have to sign a message to verify it with the Mina signer. And you can also specify everything about data instant and starting to create the new account collection. And every document will have the same formats, the same structure. Here we have the permission part. Like we handle like we handle the permission just like the way that unique like people have the who create the records will have the owner permission, and the people who have they can also share the records, the document with other people. So I call it group. Like you have with permission group and permission order here. In case that you want to just share some records with several people and you don't want the record to be public. So only people who had the permission can actually like interactive with the records. And also we allow people to look up for the document, and they can do the query to the database by using the ODM. Okay, here we're going to open, like create a new account for every people if it will not exist. So the permission endpoint allow you to also transfer the permission to the other people. As you see here, we interactive with the Merkle root and see the current state of off-chain storage is equal to the on-chain state. In this example, we're going to do a lot of transfer, and then we perform the transaction on by utilizing Zk database. So here you can use the witness to generate the witness for the document. I think like in the future we want to make everything much more simple. So it's quite simple right now, but then it's still like very hard for developer to handle all of that. Okay, this is the last check that we're going to go through every brick account and check for their balance. So we're going to start the proof service and also the serverless endpoint. So right now we can start actually like you don't have to do it because right now we do it on our own computer. That's why we have to start everything. But then in the future, you just need to specify the endpoint and everything just works. Yes. I think only logging a lot of things. So you can see that the database is changing. So here is the data cluster that we put on the MongoDB Atlas. And this is the metadata storage database. So it stores information and also the proof, the database, the collection, and no data going to be deleted from this database. It will be organized in the time series, and you can go back and forth and see and validate every stage of the database. Okay, let's move a little bit forward. So we also like store some sort of metadata about the permission group and also sequencer or proof generator service. Okay. So I think like this is the end of the demo, and here is the UI of the management tool. It is under development. Okay, so here is the summarize that what we do. In the ZK Ignite, we build the POC of ZK database and also test the capacity of O1GS. In Navigator program, we provide the GraphQL endpoint for ZK database as a service, handle user group permission and also authorization. We also implement data run-up service, build up the SDK, allow people, developer to develop their own ZK app, provide the management tool, and this one is under development. So next step, for the next version of ZK database, in the future, we want to build everything on Kimchi proof system natively. So here is our next targets for the future. We want to build a ZK modular data availability layer. We rewrite everything in Rust, build up the distributed system for data storage, implement our own ABFT consensus for data atomicity, support Virtual tree, KGG commitment scheme, Kimchi proof system, support Kimchi proof system, of course, and supports the Halo 2 proof system natively, and maybe some sort of Nova proof system. So, so we also do research about the hardware acceleration. So we want to apply it in the ZK database and help everything like improve the proving process and lower the cost for proving, lower the latency for proving. And after that, we can do chain integration. Actually, like we already have the proposal and we built the ZK memory. It actually like a path of a path of proposal that we sent to Ethereum Foundation and got accepted from them. And right now we're building the ZK memory project. I can send with you the link to this proposal and how we can build arbitrary ZK VM with this proposal. And in the future, we want to use this to utilize the ZK memory at the back end for ZK database. And right now, we have the implementation of the ZK memory in Rust and based on Halo 2. We want to bring it to the Kimchi proof system as well. So I think that it is I think it's I complete my presentation. Thank you.
Thank you very much, Chiro and Ole, for putting together a lovely tour of ZK database. There are no questions in the chat, but I have noted some down. Is this, are you aiming for this to be like a permission deployment, or can someone come, clone, and launch their own cluster of ZKDB?
I think like right now, like we allow people to try the ZK database, and they just need wallets, like any kind of Mina wallet that allow them to verify their identity. In the future, if people want to use a lot of storage and they want to buy one instant, so we can provide it. But then I hope that we can support them to purchase the storage or purchase the run-up service with Mina protocol token. Yeah.
Gotcha. Thank you. And another question I had was regarding consensus. You also had it in one of your slides. Because I understand you use Mongo database as your storage engine, and I believe it does eventual consistency. And is this impacted by ZKDB at all, or is it like completely irrelevant?
I think like right now we use the MongoDB, and actually like we have the replica sets of MongoDB, but then in the future I want to change that to a distributed system and hope that we can bring and maintain the decentralized. But then right now I cannot see any like better option that can be flexible enough to allow any kind of ZK app to be implemented. So that's why right now like MongoDB makes sense to me.
Okay. And because you're using proofs at so many places, like changing data in the storage engine, do you see, or do you have any benchmarks which I guess everyone could take a look at, or you feel it's not optimized yet enough for someone to peek into it?
I think like for the I think like I can generate a detailed bandmask for it. But then for MongoDB Atlas, everything just like very quick. Like you do everything like when you do some request to us, we just need to update the records on MongoDB and also create like sending a message to the the proof service.
Mhm.
So when people like do something, like when people like open their ZK app and do something on ZK app, actually like everything proving process and also generate the witness, the Merkle tree witness already done in the background.
Gotcha.
So that is the advantage of like server-side proving. Like
Mhm.
everything will be handled by very strong computer, and user have no idea about that. But then everything just works smoothly. So for user, the experience to use the ZK app with a ZK database, like a lot better if they do the client-side proving for now. And then like the client side proving, I think like it can reduce the cost, like the proving time, like around 4 or 5 times, because like when you do it on browser, you cannot actually do the multi-thread or access to the hardware. Yeah.
Awesome. Thank you so much for answering my questions. There isn't anything in the chat, but then if you do have questions for ZKDB, please reach out to the team. They will be on Discord, and this applies for all the presentations we've had today. And if you have made it so far, thank you very much. Chiro, you have something on your screen. Do you want to speak a little bit about it?
Yeah, this one is a part of ZK memory project, and we want to prove the RAM program like much more efficient. That's why we developed the way that allow people to prove the memory in parallel. So we hope that with this paper, with scientific paper, we can actually like improve the proving process of the ZK database.
Amazing. Thank you. So if you've followed us so far, thank you all for your attention. And season 1 has ended, but then season 2 is going to kick off 1st of June. So we'll share the links along with this video. And I hope you all have a lovely evening. Take care and thank you.
Thank you.
Bye, everyone.
Bye, everyone.
Bye.
Bye.
Bye. Bye, everyone.